Hello everyone, welcome back. Welcome back to the beginning of the afternoon sessions here at Data Science Festival. I'm just going to do a quick recap. So bear in mind, it's a hot day. Well, it's not as hot as yesterday, but it's still a pretty hot day. There is water at the back if you feel like you need it. Can I ask everyone to make sure they've set their mobile phones to silent, please, so we don't disturb the speaker and the others. And also, if you do need the toilet, there are a set of toilets there. If you do need to move throughout the presentation, just try not to disrupt other people. So, to introduce our speaker, Louis, he's going to be talking about from team building to emotion detection in 4 weeks, lifting the data bottleneck for deep learning. Louis is a data specialist, a data scientist specializing in data mining, deep learning and network analytics. An early adopter of new technologies, he is currently the data science partner at Digitas, digital agency part of Publicis Group. Prior to that, he was head of data science at Credible AI, an NLP startup, and was the first data scientist hired by Bain & Company in London, where he applied his skills to private equity, consulting and R&D assignments. Let's give Louis a round of applause.
Thank you. Thank you. Can you hear me correctly? Okay, perfect. So, who am I? I already got a small introduction. This is pretty much my past. I've deleted a few elements from it, but this is what I've done. I worked not far away from here at Market before the IPO, before the merger. That seems like a century ago, but it wasn't that long ago. I graduated from a French school, Sciences Po, also studied statistics and economics. I taught at EDEC Business School. I taught also statistics at UCL. I was a data scientist at Credible AI. Right now, I'm the data science partner at Digitas. So we are Digitas. Who are we? We are effectively the digital agency of the Publicis Group, the large advertising company, one of the biggest in the world. And we are part, at Digitas, I'm part of the data team that includes a data science team and a data analytics team. The team itself is quite big. Our data science team is growing, so I'm just making a hint. If you're thinking about applying somewhere, you might want to come to us. And I will be talking today about an AI lab that we have run inside the data science team in order to create an emotion detection problem. So this was our AI lab team. So those are the team members, 6 of them plus myself. We have the data scientists, we have data analysts, we have data apprentices. And what we've done is we have collectively put together our experiences to create a small product inside our team. So, lifting the obstacles on the path to AI excellence. Why did we create an AI lab? You might be surprised that inside a company like ours, we are actually running an AI lab. Why did we do that? Because there is a need in our industry and in our company itself to grow knowledge. Because as you might know already, the number of data scientists available is not infinite. Same thing for the data engineers, same thing for the ML engineers. And there are a few obstacles for the implementation of data science, the recruitment of data scientists, the recruitment of data engineers, and the creation of product in the data science space. Here are some of the obstacles that we see. First, there are some legacy system and architecture limits. There is the all or nothing approach where some tech teams like to go full on cutting edge technologies or keep whatever is working well for us now. And so you always have those debates, sometimes those fights between tech team and machine learning team in order to know what are we actually going to use. That's definitely an issue, especially when you consider that sometimes some technologies might not be compatible together, and so you have to re-engineer things from scratch. Another limit, again, is the skills gap and the lack of diversity. So there are a limited number of skilled people in the data science and ML engineering team. Obviously, that's not your case. If you're here today, that means you're up to date and you're keeping yourself very cutting edge. But large companies who already have large teams, they need to be able to create more data people, effectively. There is a problem with the creation of skilled employees in the data space. Another issue that the AI space is facing is, irrational expectations. I expected this to work, but it didn't quite work out. Let's see what's going on. Okay, it's back. We are back. So, irrational expectations. Too many people are looking for, effectively, unicorn data scientists and unicorn data. What I mean by that is there is in the market this idea that someone could be at the same time a mathematician, at the same time a computer scientist and a theoretical computer scientist at that, a business expert, an algorithmic developer, and a web engineer. To be honest, that doesn't exist. There is no one that is able to be covering absolutely perfectly all those different disciplines. And so in order to build things effectively, you need to collaborate and create really a culture of breaking up silos in terms of experiences. And also another problem with those expectations are the hype in the press. So you may have heard recently, for example, that a Google engineer was just put on leave because he mentioned that he believes his language model had feelings. So I don't know what you think about this, but that's the type of irrational expectations that push sometimes some clients to ask data scientists to create things that cannot exist because the technology is not there, because the idea itself was a little bit far-fetched. And so in order to limit some of those issues, we have been adopting an approach of creating labs, AI labs, during a limited amount of time, 4 to 6 weeks, where we work with the technology we need for the project, and I'll explain how we do that. We train people during those processes, so they learn the tools, they learn the practice that they need to pick up in order to be able to understand the problem and solve the problem with data science techniques. And also, we really learn to collaborate together across teams. And that's an issue that I've seen many times, not only with some of our Digitas clients, but when I worked in consulting before, you sometimes have a tech team, data team, analytics teams that really don't talk to each other and don't participate to project in common. They just pass over the baton and they are in a relay process as opposed to being a collaborative process. So what did we do to lift the architecture and legacy problem? One issue we were facing is that, for example, we are working on a particular project that we want to deploy for a particular client. We build it, let's say that that client is on one of the biggest cloud providers. We build it with some of that cloud provider's API. And then next year or 6 months later, we need to build something similar for a new client. The problem is we have used embedded APIs that are proprietary to one of those providers. And so we need to re-engineer part of the model, re-engineer part of the data flow in order to be deploying this on another cloud provider. Same thing if we have built something locally on our laptop and we want to deploy this in the cloud or to our clients, we want some reproducibility of what we have done. And so our opinion, at least for those AI labs, is to build systems that are environment independent, so cloud independent, even brand independent to some extent. And so for that, we are using Docker. So obviously, you have a number of constraints when you're using Docker. I will explain a little bit what Docker is, because some of you might not know what Docker is. But effectively, if you think about it at the simplest higher level of abstraction, what you can say is that Docker is like a mini computer. It's like a mini virtual machine that can be run in your cloud environment, that can be run inside your computer or in any environment. The advantage of Docker is that you can create a reproducible environment with Docker. And so you can abstract the particular platform that your model is working on. So that's why we go for Docker first. The second aspect is, instead of doing work in a consultative manner only, like we usually do in consulting or in services, we have, again, a strong opinion towards building APIs and building models that not only the data scientist or expert data scientist can run, but also models that a more junior data scientist could run if they fully understand how it works. And part of that is understanding the data. The last bit is more technical and more advanced. It's how do you schedule the deployment of those systems. I'm not going to talk about this today. I just mention it right now. There are some platforms to do this. The simplest one to start with is Docker Compose, because the instruction to effectively launch a Docker Compose app is as simple as Docker Compose up. And I'm not kidding, that's it. So anyone can launch a process that is running on Docker Compose. I wouldn't say the same for Terraform or Kubernetes. I don't know if anyone who knows Terraform or Kubernetes can lift their hands. Yeah. Would you say that there is a simple way to launch a Kubernetes cluster? No. Okay. Yeah, that's what I thought as well. I'm not an expert, but it's good to see that expert can confirm this. Okay, eliminating irrational expectation. The first thing we do inside our AI lab is that we discuss a few elements of research that are coming from the press, and we put them in perspective. Some of our team members are not experts. Like I mentioned, 2 of them are senior analysts in our teams that are working more on the analytics side. So they are no expert in computer vision or NLP or reinforcement learning. And what we are trying to do is to explain to them in layman terms what exactly is this application that they have seen mentioned in the press or on TV, and what are the fundamental blocks that make this work. And we found this very useful for the team to put things in perspective, and also to be able to build their own opinion or view of the different sectors or the different part of machine learning. And so we do that effectively every week. Another aspect is to demonstrate what those tools can do and what they cannot do. So the good aspect of the evolution of machine learning and data science in general in the last few years is that most of the tools have been made accessible to non-specialists via API. So in the NLP stage, you have Hugging Face. In the computer vision phase, you have things like TensorFlow Hub and other systems that allow you to effectively test an API, test a new tool or a new system very easily, and see for yourself what this is doing, if it's as magical as people say on TV. The last bit is to integrate business people in the data science brainstorming phase. What we have noticed in the past is that many data science teams were working completely in a siloed manner. And so they weren't interacting with the business people enough sometimes to be able to build a common ground or a common understanding of what can be done, what should be done, but more importantly, what does the client need and how do we get to this? So again, talking about my past experience, a few very large companies that you all know had built large data science team around 2015 to 2017. And in 2018, a lot of them starting firing them, basically massive layoff in some of those teams because they were effectively doing R&D research only and not delivering for the business side. And so we try to break this up. Okay, how to lift the skills gap? That's the biggest really challenge for most large companies right now. And one thing that we notice is that instead of just recruiting people is great, that's also something we aim to do, but there are a lot of internal resources that can be used to create more data scientists. And here are 4 different profiles that we are using in the lab. If you look at the first 3, effectively they have some specific skills and tools and expertise that can definitely be used inside a data science team. And that's why our data science team was so diverse. So when I was mentioning the analysts, they are generally pretty good at statistical analysis, which is not always the case of data scientists who are coming from the computer science side of things. On the other side, if you take some data scientists that are coming, for example, from a background in biology or a background in physics, they will have some data manipulation, data wrangling skills that are very useful in order to run labs and create products. Same thing for the programmers. They will be very good at working in agile method. They will have algorithmic knowledge. They will have software engineer practices, but might not be a statistician or might not be very good at NLP. So we try to break those silos and make people collaborate. I'll go on this. There is an optimal path, really, to convert or to create data scientists. If you look at people with a statistical analysis or insight analysis background, you can make them enter the skills of data science by pushing them toward pandas data frame, so Python pandas data frame. Why? Because everyone that has worked in R is working with data frame, and for them, bridging the gap between R data frame and Python data frame is very easy. So if you make them enter through this route, they will very easily get inside the Python ecosystem, and from that point, they can learn scikit-learn, PySpark to do manipulation on large data and also machine learning on data. If you look at programmers, database, cloud specialists, they are generally pretty good at SQL. So you can make them enter through the Spark SQL entry point. So Spark SQL is basically SQL on Spark, but inside Spark, you also have Spark ML, which can help making them fluent or understand effectively how to run machine learning processes on the data. So you give them an entry point where they are already comfortable so that the gap is not too big between where they are and where they need to go. Data science beginners with Python knowledge, if they already know Python, the best entry point is scikit-learn. Again, in the Python ecosystem, and that's the direct next step. For full beginners, they need to learn some Python and SQL. So there's no other way around it. And so that's something we recommended to our junior team members as well. Okay, the lab solution. The way the lab solution is organized is, first, we create a team with people with the knowledge and the tools that we mentioned. And we create that team around a specific business purpose. Then we try to learn as fast as possible during 4 or now 6 weeks. I will talk about this later on. Then within the lab, we pair people with different skill sets. And the last important element is that everyone, and that includes me in this team, everyone needs to be manually labeling data. I know people don't like to do that. I know people like to say, oh, let's just externalize this. We'll do this offshore. Actually, that doesn't work. If you worked on real industrial application and you have effectively another team in another country or in another company labeling your data, and that team doesn't fully understand your business requirement, how you're going to operationalize the model, and what's the standard that you expect, you're going to just waste your money. And so it's important for everyone to understand the data at the fundamental level, and you can build from this. So in our case, we had several stages. First, the exploratory data analysis. Second, we explored data generation. Third, model design, then model analysis, model deployment, and model monitoring. We actually didn't get to model monitoring in the 4 weeks, but I'll talk about this later. Okay, building an emotion detection system in 4 weeks. I'll give an example of what we aim to do. So the lab aimed at improving an emotion classifier that would inject text from review websites or from customer feedback and detect the emotion included in the sentences. So if you see here, you have a few comments here, and then you have 11 different emotions. And the model is basically trying to predict which emotion was included inside this specific comment. So here, the comment is truncated, but it's a much longer comment. So one problem we noticed when we started looking at this with sentiment analysis, because a lot of people are using or buying sentiment analysis, is that if you're looking at a sentence of a review that is relatively long, that is not just a small tweet, you may have both strongly positive and strongly negative element in that comment. And when you look at tweets, it's not so much the case. But if you look at Trustpilot data, for example, where people actually make some reviews, one thing that came up while we were looking at the data and doing the exploratory data analysis is that you have a lot of comments where the first part of the sentence, the user is saying, I really hate this company, this is what they did to me, that's really outrageous. And in the second part, they say, luckily, Louisa helped me, and she figured out everything, she's amazing. And what happened when you just scoring your sentence with a sentiment analysis model is that it will just average both sides of those sentences and will tell you, oh, this is mildly negative or this is mildly positive. And that's definitely something you don't want. You want to be able to pick up the fact that on this particular topic, there was some anger, but that some joy came from another process. And if I come back to the previous slide, one thing we've done is we've used also named entity recognizer to extract the names from those sentences. And that proved very useful. Why? Because in general, when you had those models with two emotions, like in that case, it's joy and optimism, so they go in the same direction. But when you had comments with opposite polarity, so a positive and a negative emotion, most of the time, that was due to the fact that someone actually intervened, that a customer agent intervened and solved the problem. And so doing named entity recognition on this sentence to extract the fact that there was a name there was very useful in interpreting those comments. And same thing, if you look at the next slide here, what you can see, so that's a topic. I don't know which one of those, actually that's for another model, but you have those topics, and then you can see for particular topics, because we're linking this with a topic model, for a particular topic, how much optimism you had, how much joy, how much disgust, how much anger, and obviously you could generalize to more emotions. So one thing I will mention there, to do the topic modeling for people who are very interested into NLP, you should definitely look at a model that is called BERT topic, which effectively is a new way of doing LDA and topic modeling on data. That's something we are using inside this model. I'm not going to go into the code, but that's what's behind this classification. Okay, at a high level, what is our model relying on? It's relying on a transformer model, on one type of model called Roberta, that was the second generation after the big revolution that was the BERT model. And what those transformer models have, those large language model based on transformer have in common are two things. So you have a language model and you have a self-attention element to it. So the language model, all that is happening here is you start from words, so you have the student open there, and for each word, basically, you have a numerical vector representation. So in that case, this word Z has this numerical representation. This word student has that one. And so what you do with those language models is you're trying to predict the next word that is going to come after this one. And that's how those models are trained. So when you have the student open there, then you make a prediction, and based on whether that prediction was correct or wrong, the model will update itself to keep getting better. And so at the first level, it creates those vectors, then put them together, put them through a model, and then you have probabilities for what the next word might be. So in that case, you have the student open there, and the most likely next word is books. Does that make sense? Okay, so that's the first aspect of those large transformer models. The second aspect is self-attention, and self-attention is the fact that those words that you see here, in the first generation of NLP models, they were fixed. So we would say this is the representation of the word Z. What's happening now is while you're pushing the data through the model, those representations themselves will basically be updated or will be changed based on effectively correlations that they have with other words inside the sentence. And so we call this self-attention because one sentence is looking effectively at itself and calculating weights between the one word and the previous, or one word and previous word in the sentence. Okay, so a few steps we went through. First, we went to emotion definition. That was critical, and that's something that you generally lose when you're doing a lot of offshore work, is that you don't spend the time to make people converge around what is necessarily a good labeled example. And when you do those emotion definition, we actually have written down a few definitions, and we tested them. We tested them by labeling some of the same data point and discussing later on why do we agree, why we don't agree. Then we went through a data creation process. The data creation process was using a model or a framework called Snorkel that allows you to create small labeling functions to generate data. And then you can look at the quality of that data later on. Okay, week 0, pre-lab work. Pre-lab work was a few explanations, a little bit more in depth, of course, on language models and what we have looked at. We recommended some short courses and some references that people could look at. We were sharing articles with everyone as well. We did some demo, and then we started using Trello to implement an agile method. And yes, we explained the basic of ML approach, both neural network and language models. Okay, then this is a detail. We don't need to spend more time on this, but basically we created our own Docker container and our own environment that we shared across the team. Then we focus on the data. I've talked about this already. We spend a lot of time agreeing on the labeling. We spend some time on Snorkel generating data. And we constantly kept thinking about how we could generate more data or get better data. That phase of data creation actually never stops. Then emotion definition. Those are the 11 emotions that we define. I didn't put our definition there, and possibly from client to client or use case to use case, you might have your own. Then we started augmenting the data. What I mean by this is we use some weak supervision methods to try to generate data. So one example of what weak supervision could be, for example, is to look at data you already have, and based on this data, you try to generate more data. So one example I could give is if we had those emotions, right? We have here surprise and we have sadness. If we wanted to create a new sentiment, for example, disappointment, I would say that disappointment is sadness plus surprise. And so all the data already have labeled as sadness plus surprise. I could, in a first implementation, label them as disappointment. Okay, week 3, train the model. We show the architecture and components. We show the framework, and we show the fine-tuning strategy. So the architecture and component, in our case, like I mentioned, we base the model on Roberta, the Roberta language model. The framework we chose was PyTorch. If you're starting to learn machine learning or deep learning, please don't pick up TensorFlow right now. TensorFlow was great when I started, actually a bit after I started, but now Google itself is moving to another framework called JAX. So if you want to stay in the Google system, please learn JAX. Otherwise, PyTorch is very easy to use, so that's a recommended system. And choose a fine-tuning strategy. So what I mean by fine-tuning strategy is how do you get from the open source model that was built by Facebook or built by Google with millions of dollars to the answer, the business answer you want to have. And this is being done by using a fine-tuning strategy. And what that means is you create a model that includes the Google or the Facebook model or the open source model inside it, and you just give it a new thing to predict. And as it's trying to predict, you make the weight or the representation of the words evolve until you're getting good result on your task. Week 4, deploy the model. Here I put FastAPI, ONNX, and TorchServe. We did FastAPI, ONNX. I'm not going to talk too much about this, but effectively FastAPI is a way to create an API endpoint. So if you think about it, it's like a URL to which you send data and you retrieve data from. ONNX is a system that allows you, that was created originally by Microsoft, and it allows you to move from the PyTorch ecosystem to the TensorFlow ecosystem or the JAX ecosystem by effectively saving the model into a standardized format that could be deployed with other tools. And TorchServe is a Torch-based system to create also a higher, a lower latency type of model. Next step, lower the latency again. Use ONNX to deploy with TensorFlow serving. So TensorFlow serving is a really robust method to deploy a model, and with both REST API and gRPC to have basically quick response times. And you don't need to have built your model in the TensorFlow ecosystem in order to use TensorFlow serving. You can build your model in PyTorch, export it as ONNX, and then use TensorFlow serving to put it in production. And Docker plus TorchServe gRPC is another way to have a PyTorch system being deployed. There is a new one as well. Now I forgot its name, but those things are moving quite quickly. Okay, running a lab. A few learning we have made in the process. First, I mentioned this at the beginning, but all team members had to label data, and that proved very useful. It had many positive externalities, but the most important one is that everyone understood the business problem at a very fundamental level, and also everyone could collaborate together. Then multi-labeled training can be difficult. So this is more of a technical aspect of it, but if you build your system so that it can learn from the error of the model to predict what you're trying to predict, when you have multi-label system, some of the categories that are wrongly predicted can influence the rest of the training for those other categories. So that's something to have a look at. For training the model or even implementing the model, if you're taking a model that was open source and that was running fine, beware that that model may have been built on a machine that is way more powerful than yours. And so you might have to reconfigure the length of the data input that you're sending to it, and also the batch size. The batch size for out of memory error. The max length is actually a little bit more subtle, because sometimes when I showed at the beginning a sentence and we transformed those sentences into vectors in order to go to the prediction, we only had 4 or 5 words, so it didn't make a difference. But those language models generally have a maximum length of either 512 or 768. And if you don't pay attention and you have a default value, only part of your sentence will be considered as input. The rest will just be truncated. Okay, it was to avoid not checking the learning process on a single batch. It's always useful to check that your model can learn something on a very small data set. If it cannot overfit on a very small data set, it's very unlikely that it will ever be able to fit on a larger data set. Not setting up some reproducibility metrics by setting the seed and deterministic seed numbers. And relying on open source data only, you would be surprised of the quality of the data we've seen in some open source data that are everywhere on Kaggle and so on. And when you actually look at the data, you realize that sometimes the quality is not great, even though some of those papers were used for academic publications. Saving the model correctly critical. That's another thing that surprised some of the team members initially. So when you save the model with the default method, that is the easiest, the model will expect even the folder structure whenever the model is being deployed. And so you're better off effectively using a saving method that is capturing all the weights as a dictionary, and it will be easier to deploy later on. A model deployment, fast API to the rescue. If, like me, you're not a web developer, because as I mentioned at the beginning, this unicorn data scientist probably doesn't exist. You need something that allows you to show people what is working and how it's working. It's very easy to build a fast API deployment model, and it literally takes an hour or less. And so that's very useful. Watch out, your named entity have filling too. That was quite surprising in our case. One thing we mentioned, we noticed, okay, I have it here. One thing we noticed is that some of the names in those reviews had positive or negative sentiment attached to them. And that came from the base Roberta model. And what you see here is effectively the same sentence, the same sentences for one call agent. When this agent basically when the name was kept in the sentence, that agent had more positive reviews than when we replace their name by a neutral name like agent. And so what that means is when the sentiment analysis was getting calculated, there was a positive element that was generated by the name Ami. And you obviously don't want this. So what we are doing when we are doing those customer reviews, we do name entity recognition, and we replace the name with a neutral or constant a name like agent, for example. Okay, takeaway, I already mentioned a few of them. Running an AI lab is an efficient way to grow AI skills. Learning how to create or enrich data is critical. Check for bias, use Docker, get in touch if you want to run your own AI lab. And that's it. That's how you can get in touch. Thank you.
Okay, we only have a small amount of time for questions. So there's a young lady at the front.
Sure.
Just wondering, like, in terms of data labeling to do the fine-tuning, did you use any kind of specific tools for that?
Yes. So for the data generation or the data labeling? For the data labeling, we didn't use any tools in the end. We checked Label Me and we checked Prodigy. We didn't want to pay a license for Prodigy. I don't know if I should say that, but that's a fact. But when we are going to run industrial product, that's definitely something we'll buy and use. So that's the first thing. We use a framework called Snorkel to generate the data. And what we observed doing our lab is that people who are not familiar with Snorkel didn't get up to speed quick enough for the duration of the lab. I used it personally in the past, but I had a lot of time. What happened with Snorkel is you need a minimum coverage level on each sentence, and if that coverage level is too low, you basically can't build a model. Yeah. Yeah. Oh, sorry.
I was not here in the beginning, but I believe Digitas is a consultancy company.
So Digitas is part of the Publicis Group, which is a large advertising company. And inside Digitas, we have a data team with an analytics team and a data science team. And we do anything around data we can do, basically.
My question.
Yeah.
Are you seeing a lot of this trend of merging data analytics and data science and call now the full stack data science?
Yes. Yes, not only at Digitas. My experience is that there are two things. The first thing is a lot of people on the analytics side actually are always taking a peek at what data science is doing and understand that some of the process they do normally in a consultative only way could be automated, could be made into products. And so themselves, they push toward the data science aspect of things. So that's one source. The other thing I'm seeing is that sometimes the data science team is brought in to effectively update some of the processes that were run as analytics processes only. So that's what I'm seeing. There was a question.
Sorry, that's all we've got time for, I'm afraid. Louis, thank you. Great talk and
Thank
well
you very
done.
much.
Fantastic answer to the questions. Round of applause for Louis.